In this video, we show how to find the difference quotient of a few functions. The difference quotient of a function f is given by this statement here, where h is not equal to 0. Essentially, the difference quotient gives us the slope of a tangent line to a curve. All right, so this white line here is some curve. And at some point along the curve, this line, there's a tangent line to the curve, and that is given here in blue. And we may want to know the slope of the tangent line as h gets really, really small and very close to x. This concept is used in calculus to define the derivative. All right, let's look at a few practice problems. All right, suppose we want to find the difference quotient for each function below here. And suppose this is the first one. There's just a few. All right. So first we begin by go ahead and write the difference quotient. So that is, we need to find f of x plus h minus f of x over h. And so it looks like we're going to need to find f of x plus h. We need to know what that is. We already know what f of x is. That was given to us. So we just need to find f of x plus h and then substitute it in and then simplify. All right, so let's go ahead and find f of x plus h. This just means that everywhere we see x, we're going to replace it by x plus h. So we're going to have x plus h here minus 2x plus h plus 6. All right, and then we want to simplify this. Alrighty, and then we want to simplify a little further. Just using the FOIL method here. All right, so now we found f of x plus h, and all we do now is substitute this back into this, difference quotient. So we're going to have f of x plus h, f of x plus h minus f of x equal to 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 6 minus 3x squared minus 2x plus 6. All of this is over h. Now, this right here, you notice how I had to put this parentheses, for f of x. So here is f of x plus h right here, and then here is f of x. And notice that in the formula, there is a minus here, so that's this minus. So this minus has to be distributed throughout the whole f of x. And that's a common mistake that people make. Right? So after we distribute that negative throughout, we're going to have all right, so this is going to give us now certain terms cancel out. So 3x squared cancels out with the negative 3x squared. Positive 2x cancels out a negative 2x. Negative 6 cancels out a positive 6. And it looks like we are left with 6xh plus 3h squared minus 2h all over h. And when we divide h throughout each of these terms in the numerator, we're going to have a final answer 6x plus 3h minus 2 as our final answer for the difference quotient. All right, let's do another one. This time, same thing. Even though they give you a function g of x, it's the same idea to find the difference quotient. So this time we want to find g of x plus h minus g of x over h. So we're just going to we need to find g of x plus h. We already have g of x. So what is g of x plus h? G of x plus h is everywhere I see x in the given function, I'm going to replace that x by x plus h. So we're going to have x plus h, x plus h plus 3. Right, so g of x plus h is, I'm just going to leave it like this. All right, and then now that I know g of x plus h, now I'm going to substitute this into the function, into the difference quotient rather. All right, and let's see what we're going to have. We got g x plus h minus g of x over h. This is going to make us have 2x plus h, x plus h plus 3 minus g of x, which is 2x over x plus 3, all of this over h. Now, I'm going to clean up this numerator and try to combine these two terms in the numerator. And in order to do that, I'm going to get an LCD. LCD is this product here, x plus h plus 3 multiplied by x plus 3. So that's going to give us, 2x plus h over x plus h plus 3 x plus 3 Now I'm going to pick up x plus 3 in this numerator minus 2x, and over here in this numerator, on this side, I'm going to pick up a x plus h plus 3, right? To make equivalent numerators all over h. All right, now I'm going to simplify this numerator here by multiplying this all out, and that's going to give us 2x squared plus x plus hx plus 3h minus 2x squared minus 2xh minus 6x. All of this over x plus h plus 3 x plus 3. All of this over h. All right, this problem is kind of long, but we have to simplify it to the point where if we let h become 0, it's not going to be undefined, right? We have to simplify it so that h can become 0, and the statement is still valid. So let's go ahead and keep simplifying. So we're going to have, in the numerator here, we're going to have 2x squared plus 6x plus 2hx plus 6h minus 2x squared minus 2xh minus 6x all over x plus h plus 3 x plus 3 all over h. All right, now in this numerator here, we see that we've got common factors that can be canceled. So positive 2x squared cancels the negative 2x squared. Negative 6x cancels the positive 6x. Positive 2hx cancels the negative 2hx. So this simplifies our we get now 6h over x plus h plus 3 x plus 3, all of this over h. And you can see that now this thing simplifies to 6h over h x plus h plus 3 x plus 3. All right, and now our h's cancel out. So a final answer is going to give us 6x plus h plus 3 over and x plus 3 right here. So here, if I take h to become 0 or very close to 0 or even 0, the denominator is not going to be 0, right? So this is still valid. We don't run into anything being undefined, right? So this is the final answer here. All right, let's do one more. Find the difference quotient for a radical function. Same idea, that is, we want to find p of x plus h minus p of x all over h, right? We want to find out what is this equal to. So we just got to simplify this. So first of all, we already know what p of x is. We just need p of x plus h. And again, to find p of x plus h, everywhere we see x, we're going to replace it by x plus h. All right, so here's p of x plus h already. And now we just substitute this in to the difference quotient. This will make us have p x plus h minus p of x over h, which is going to give us x plus h plus 1 minus x plus 1 over h. Now, if h were to be 0, this would be undefined, right? So we can't have this. We can't have an expression that's undefined. So we have to simplify further so that we can allow h to become 0. All right, so we're just going to go ahead and rationalize the numerator. All right, so to rationalize the numerator, we're just going to multiply top and bottom by the conjugate of the numerator. And the conjugate of the numerator is square root x plus h plus 1 plus square root x plus 1 x plus h plus 1 plus square root x plus 1. All right, now when we simplify this, so we're multiplying all of this to this. All right, so we're going to do FOILs. So first, outer, inner, and last. All right, so when we do first, outer, inner, last, we're going to have square root x plus h plus 1 all squared. Now, outer and inner is going to cancel out to 0. So we're only going to have the last, which is a negative x plus 1 squared. And the bottom is going to become h square root x plus h plus 1 plus square root x plus 1. All right, that was the purpose of us multiplying top and bottom by the conjugate, because it would make this numerator, the two middle terms cancel out. All right, so then we're going to have here x plus h plus 1, because the square cancels out a square root, minus x plus 1. Now this negative here is after the square cancels out the square root, this negative is distributing throughout that second parentheses. So this is giving us now x plus h plus 1 minus x minus 1, and LCD, not the LCD, but the denominator, which is h square root x plus h plus 1 plus square root x plus 1. And you could see here now that a positive x cancels a negative x. A positive 1 cancels a negative 1, which has given us a final answer of h on the top, h on the bottom, x plus h plus 1 plus square root x plus 1. All right, and those h's divide out, and our final answer is 1 over square root x plus h plus 1 plus square root x plus 1. And this is definitely allowable because when h is 0, the denominator is not undefined. All right, so this is the final answer. And I hope you found this video to be helpful. If so, like and subscribe. This was part of the math of numbers and symbols, but math is order in the broadest sense.